Hi everyone, my name is Ismail Shugeke. I am an experienced mathematics teacher and a master coach at Smart Mind Science Academy. Today I will be explaining and exposing the concept of algebraic identity. In mathematics, algebra is an aspect of mathematics that deals with numbers and letters. It deals with numbers and letters. Identity is just like our national identification number, NIN. So your identity is what stands for. Our bank verification number, BVN, is a number that stands for us. Our phone number is also a number that stands for us. So identity is just the same way. For example, this A plus B, all raised to the power of 2, has its identity. So this is the first identity, this is the second identity, the third identity, the fourth identity, and the fifth identity that we'll be considering today. This first identity, A plus B, all raised to the power of 2, is square of a sum. This second identity, square of a difference. This third identity stands for difference of two squares. This fourth identity stands for sum of two cubes. This fifth identity stands for difference of two cubes. Now the first identity is square of a sum. You can see we have a sum and we have its square. This second identity, square of a difference. We have a difference and we have the square. This third identity, a squared minus b squared, it is so common and it is unique. It is difference of two squares. Difference of two squares. This fourth identity, a raised to the power of 3 plus b raised to the power of 3, it stands for sum of two cubes. And this fifth identity stands for difference of two cubes. You can see sum, difference, then difference of two squares. So that is what these identities stand for. Now, how do we express them? What is their evaluation? What is their simplification? Now, how do we express these 5 identities? What is their simplification or evaluation? The first identity is sum of a square. A plus b raised to the power of 2. In mathematics, whenever you have an expression like this, you have to write this a plus b 2 times. For example, if I have x squared, it means express x 2 times. X times x. Take note of my x and my multiplication sign. Also, if you have 3 raised to the power of 2, it means write 3 2 times. 3 times 3. 3 raised to the power of 2 is not 3 times 2. So it means express 3 2 times. Express x 2 times. So with this explanation, I am going to write a plus b twice. So I have a plus b, a plus b. I can expand this bracket. I can FOIL it. So I have to multiply these two values together first, then these two, then this, then this. So I can use a system that is called FOIL system to multiply. F stands for first, O stands for outer, I stands for inner, and N stands for last. So I multiply this, the first value first, then the outer value first, outer, then the inner value, then the last value. So first value, a times a, that gives a squared. Then the outer value, a times b, that gives ab. Then the inner value, b times a, that should be ba. But in mathematics, we want to write in alphabetical order. A comes before b, so I have to write a before b, not b before a. So I have ab, then b multiplied by b, I have what? B squared. So from here, ab and ab is just like we have 1 and 1. There's an understood one. Yeah, 1 and 1. So I can add the two ones together and it becomes 2. So a squared plus 1ab plus 1ab, it becomes 2ab plus b squared. So this identity, sum of the square, can be expressed as a squared plus 2ab plus b squared. So if I am asked to expand this 3 plus 2 all raised to the power of 2, I can use this identity to expand this because I already know what this identity stands for. So my 3 will be my a and my 2 will be my b. So I have 3 squared plus 2ab plus 2 multiplied by 3 multiplied by 2 plus b squared, 2 raised to the power of 2. So that gives me 9 plus 2 times 3, 6, 6 times 2, 12, plus 2 times 2, 4. 9 plus 12, that is 21. 21 plus 4, that gives 25. Class, even if you do 3 plus 2 to be 5, 5 squared is still 25. So this is just a more convenient way of expressing this. To factorize this, 3x plus 2y raised to the power of 2. You don't need to stress yourself. This is just like our sum of a square. You can see sum of a particular square. So we know if this is my a and this is my b. So my expression is going to be a squared plus 2ab plus b squared. A squared plus 2ab plus b squared. That's one of the ways you can understand or remember this identity. A plus b squared. To remember it, you just do a squared plus 2ab plus b squared. Now I want to expand this, or I want to factorize this. 3x plus, so I am asked to solve this 3x plus 2y. This 3x is going to be my a and this 2y is going to be my b. So I'm going to follow this pattern. So a squared, I have 3x squared plus 2ab. So 2 into bracket, my a is my 3x and my b is my 2y plus b squared, which is my 2y squared. So I have 3 squared is 9, x squared is x squared, plus 2 times 3, 6, 6 times 2, 12, xy, plus 2 squared is 4, then y squared is y squared. So my 3x plus 2y all squared is equals to 9x squared plus 12xy plus 4y squared. So that is for square of a sum. Second identity, the second identity is difference of a square. Difference, you can see we have a subtraction sign here. Difference of a particular square, a minus b all raised to the power of 2. In mathematics, whenever you want to expand this, do not forget, you have to write a minus b twice. So I have a minus b, and we have to FOIL this. So we do the first values first, a times a squared, then the outer value, a times minus b, minus ab, then the inner value, minus b times a, minus ab. Do not forget, we do not write minus ba, we rather write minus ab. Then minus b times minus gives plus, then b times b gives b squared. So from here, I have a squared minus ab minus ab. Do not forget, now class under sign rule, I explained that whenever you have two negative signs, you pick one of the negative sign and you add the values together. You have a 1 here and you have another 1 here. So minus, minus, you pick one minus and you have the value. 1 plus 1 becomes 2. Then you drop AB plus B squared. So A minus B, all raised to the power of 2, is the same thing as A squared minus 2AB plus B squared. So this is the identity for A minus B, all raised to the power of 2. Difference of a square. So if I am asked to expand or evaluate this 3x minus 2y, all raised to the power of 2 class, this is going to be my A and this is going to be my B. Do not forget, this identity is difference of a square. It can be expressed as A squared minus 2AB plus B squared. Class, my A is 3x. So I have 3x all squared minus 2ab, 2 into bracket. My a is 3x, then my b is 2y, plus b squared. My b is 2y all squared. So I have 9x squared minus 2 times 3, 6, 6 times 2, 12, then xy, plus 2 raised to the power 2, that is 4, then 1 raised to the power 2, that is y squared. So my 3x minus 2y all squared expressed as what? 9x squared minus 12xy plus 4y squared. Do not forget the identity. A minus b raised to the power of 2, a squared minus 2ab plus b squared. But if you have the sum of the square, do not forget sum of the square is a squared plus 2ab plus b squared. First identity is difference of two squares. If you have two squares, a squared minus b squared, what does it factorize into? How can you express a squared minus b squared? Difference of two squares is very, very simple, and it is one of the most simplest expression in algebraic identity, because it is going to factorize into a minus b, a plus b, a minus b, a plus b. A squared minus b squared, it can be expressed as a minus b, a plus b. Very, very simple. Whenever you have two squares, it becomes a minus b, a plus b. So if you want to be sure what you did here is actually correct, you can just multiply these two values together and see if you get the same thing. What we do is we FOIL them. The first value first, a squared, that is a times a squared. Then the outer value, a times plus b, we have plus ab. Then the inner value, minus b times a, minus ab. Then the last value, minus times plus minus b times b, b squared. Class, we have a plus ab and a minus ab, so they are going to cancel out because they have opposite signs, they have different signs, and they are equal value. So a plus the value and minus that same value cancels out. So we have a squared minus b squared. You can see I have my roots back. Difference. So I have my roots back. Difference of two squares. So if I want to express 4 squared minus 3 squared, I can just do difference of two squared for this. 4 plus 3 multiplied by 4 minus 3. So 4 plus 3 is 7. 4 minus 3 is what? Is 1. 7 times 1 is what? Is 7. Even if I do 4 raised to the power 2, that is 16, minus 3 raised to the power 2, that is 9. 16 minus 9 is what, class? 7. So I still have my answer and my value. And that is that on difference of two squares. Next identity is sum of two cubes. Sum of two cubes. Class, sum of two cubes is going to factorize into a plus b, a squared minus ab plus b squared. A plus b, that is the first value, a plus b, without any square or any square. So you take the a square, then you remove ab, then you add b squared. A square, remove ab, then add b squared. So let us factorize this and see if what we actually did is correct. Multiply all these values with a, then you multiply all these values again with b. So I want to multiply all through with a. So a times a squared, that gives a cube. A times minus ab, that gives minus a squared b. A times b squared, that gives ab squared. A times a squared gives a cube. A times minus ab. This a is just attacking the a. A times a becomes a squared, then you put the b. Then a times what does not even have a before. You just put the a and put the value. As simple as that. Then you also use b to attack all what you have in this other bracket. B times a squared. A squared does not have b, so you have just what? A squared, and you put the b. Then b times minus ab. B will attack b, it becomes b squared. Minus ab squared. Then b multiplied by b squared. You have what? 3b's now. B multiplied by b squared, you have what? B cubed. Now, there are some things that can factor out. Minus a squared b plus a squared b, they are the same, so they can cancel out because they have what? They are the same value with different what? Signs, so they cancel out automatically. AB squared plus AB squared minus, they also cancel out. So you are left with what? A cube plus B cube. So as simple as you might have 3x raised to the power of 3 plus 2y raised to the power of 3. And you have to factorize, you have to evaluate or express this in its identity. So what you just do is you pick 3x and plus 2y first. 3x plus 2y, because this is going to be your A, this is going to be your B. So A plus B first. Then you do A squared, which is 3x squared. Don't forget all squared. Minus AB. Multiply them together. 3x multiplied by 2y plus B squared plus 2y squared. 2y all squared. Then you close the brackets. So from here you can still solve some things. 3x plus 2y. 3 squared is 9. Then x squared is also x squared. Minus 3 times 2, 6. X times y, xy. Plus 2 squared, that is 4. Y squared, that is y squared. So this is what the identity 3x cubed plus 2y cubed is going to give us this. The last but not the least is difference of two cubes. A cube minus B cube. It is so similar to sum of two cubes. What you just need to do is to write your A minus B, then A squared plus AB plus B squared. So you can see I wrote A minus B first, then I brought out A squared, I added AB, and also I added B squared. As simple as that. If you want to be sure if this is actually correct, you just multiply A through by all what you have here. You multiply minus B through by all what you have here. Multiply by A squared, you have A cube. A multiplied by AB. So A is going to attack A, it becomes 2A's, that is A squared, B. Then A is going to multiply what does not even have A at all. So you have AB squared. Minus B times A squared, you have minus A squared B. Minus B times plus AB. So minus times plus gives minus, then B multiplied by B becomes B squared with respect to A, B squared, then minus times plus becomes minus, then B multiplied by B squared becomes B cubed. So there are some things that can go. A squared B minus A squared B, they are the same value with different signs. So we cancel out. Plus AB squared minus AB squared, the same value with different signs. So they cancel out. So we are left with what? A cube minus B cube. So I'm actually sure that A cube minus B cube, its representation or its expression is this value that I have 3x raised to the power of 3 minus 2y raised to the power of 3. Then my expression is, this is my A and this is my B. So I'm going to write AB first, subtracting them. Do not forget minus. So 3x minus 2y. Then I'll open another bracket. I'll write A squared. Next, 3x, don't forget, all squared, plus, then I multiply my A and my B. 3x, 2y, squared, plus I square my B. 2y squared. So from here, I have 3x minus 2y, all into bracket. I can still solve this. 3 squared is 9. And x squared is x squared, plus 3 times 2, that is 6, x times y, xy, plus 2 squared, that is 4, then y squared, that is y squared. So my A cube minus B cube gives 3x minus 2y, 9x squared, plus 6xy, plus 4y squared. So summarily, sum of a square, A plus B squared gives A squared plus 2AB plus B squared. Difference of a square, A minus B squared. It is the same thing as this. But the difference is you have a plus here, you have a plus here. You have a minus here, you have a minus here. Difference of two squares, very, very simple. A squared minus B squared. You have A plus B, then A minus B. Sum of two cubes, A cube plus B cube. AB first, you square A minus A times B plus square B. Difference of two cubes, the same thing as this. But the difference is you have a plus here, you have a minus here. So you have a plus here, you have a minus here. You have a minus here, you have a plus here. As simple as that. Do not forget to like and share this video. And if you have any question, do ask. Don't forget to join our free class that is scheduled to hold on the 19th of February 2022, where I will be sharing strategies that can help your child get grade A1 in mathematics, WAEC, NECO or GCE, and score high in JAMB. Thank you.